Friends, welcome to Damu Education. If not yet subscribed, please subscribe and click the bell icon. So in this module, we are going to discuss our sixth question. What is that in similar triangles first exercise? What they are asking here is, in the given figure, they are given two parallel lines. So here what is that? DE is parallel to OQ. DE is parallel to OQ, and next one is DF is parallel to OR. DF is parallel to OR. Then show that here EF is parallel to QR. EF is parallel to QR. So what are the given conditions? What we have to prove and what is the proof? You have to, three steps you have to remember while solving any question. Given and required to prove and proof. So first one, what are the given conditions? So given that, what you can write, given that DE is parallel to OQ. So DE is parallel to OQ. So these are the two parallel lines, OQ, and DF is parallel to OR. So DF here are parallel to OR. So DF is parallel to OR. So these are the two given conditions. Next, what is that given condition? Required to prove, RTP. So that is required to prove is EF is parallel to QR. EF is parallel to QR. This is parallel to QR in a triangle PQR. Then what is the proof here? Let's write it. What is the proof? So proof will be, let's take proof. So triangles, you have to consider triangles differently. So this section, so this is the section, this section from this divide that. So triangle from Thales theorem. So by using of Thales theorem, we are going to divide. What is that? By using of, if it is a parallel to the third side, it will going to divide the other two sides into equal ratios. That one we know. So from basic proportionality theorem, that is BPT, Thales theorem. So basic proportionality theorem, from Thales theorem, what you can write it from triangle, what is that? POQ, from triangle POQ, what is that? POQ, here POQ. So ED is parallel, what is that? ED is parallel to OQ, ED is parallel to OQ. That means what you can write here, PE by EQ, PE by EQ will be equal to PD by, what is that? PD by DO, PD by DO. So that is the case here. So PE by EQ will be equal to PD by DO. It is dividing in this. Why? Because ED is a parallel to the third side, that is OQ. This is the one. From triangle, let's take, this is equation 1. From triangle POR, from triangle POR, what is that? DF is parallel to OR. DF is parallel to OR. It is also by using of proportionality theorem only, by using of Thales theorem only. If one line is parallel to the third side, which is joined from midpoints of two sides, that line is divides two sides into two equal ratios. So that means, what is that? PD by DO, PD by DO will be equal to PF by FR, PF by FR. So from equation, this is one, equation 2. So what approach I am taking here is, wherever it is a parallel is there, let's take the triangle and write proportionality theorem, and you can take it as it is by using of definition. So from 1 and 2, what you can write, PD by DO will be equal to PE by EQ, that will be equal to PF by FR, PF by FR. Therefore PE by EQ will be equal to PF by FR, PF by FR. So if you want to show the lines are parallel, you have to go for the converse of basic proportionality theorem or converse of Thales theorem. If you want to show this one proportionality, that is equal ratios, then you can use what? Thales theorem. So by converse of Thales theorem, basic proportionality theorem, converse of Thales theorem, what you can write, if two ratios of sides any line, so here EF, this line is divides, so triangle PQR, in that triangle PQR, in that EF is divides into divides the sides of sides, that is PQ and PR. PQ and PR. In triangle PQR, EF is divide the sides PQ and PR into equal ratios. That is PE by EQ will be equal to PF by FR. That means, so what you can write, EF is parallel to QR. EF is parallel to QR, hence proved. So by using of converse of Thales theorem, by using of converse of the basic proportionality theorem, we can say here EF is parallel. You can write it like this also. EF is parallel to QR. Like this also you can write it. Thanks for watching. If you like the video, please like it. Try to share with your friends and family members. Don't forget to subscribe.